like eons ago, but way back when at the start of the year, we were solving linear equations, okay? And what makes it linear is that there's no sort of x squared or x cubed, or there's no division of x. And we had a definite game plan of how to solve these types of questions. Would you agree? So if I had this, do you remember how would we solve something like this? What's our plan of attack? First, don't like the 5. So we can get rid of that divide by 5 by timesing. And same, if I had had this one divided by, then you do the cross multiply thing. But for now, we can just times by 5. Could put brackets, but I'm just going to go 15x, take 10, please don't yawn, equals 4 minus 4x. We expand that bracket as we go. Yeah? Happy with that? Again, we have a distinct game plan. What is our goal here? To get x's on one side, yeah, and non-x's on the other. So we end up with 19x, because to get rid of the take 4x we add, to get rid of the take 10 we add, we get 14. To get rid of that times 19, we're going to divide by 19. And the whole point is that it's this one, this singular value, that if you sub back up into here, it will make that equation true. It'll make it equal. Does that make sense? What we want to do now is take it up a notch, and you did some of this last year. We're going to refresh your memory. I would like you to solve something like x squared plus, let's go with a 10x equals negative 16. So I love that face, Mia. If everybody could turn and look at Mia's face when you say, go on, do it. He was like, screwed up face. So how am I meant to solve something like that? The game plan that we had here isn't going to work. We've got our x's on one side, but how am I meant to solve it? Like, I could get rid of a squared max, but that's not really going to help, because then I've got icky square roots and stuff. It just doesn't work. So what are we going to be able to do to solve this? And by the way, this is what we call linear. This is, because of the squared here, this is what we call a quadratic. All right, when we have an x squared, we have a quadratic equation. We want to solve that. We're going to have several methods of solving these. Huzzah! And one of these methods is called factorising. We will also go and look at a thing called completing the square. There's a formula that you can use. There's also your graphics calculator. Okay? But the whole reason why we want to remind ourselves of factorising is because we want to eventually solve quadratic equations. What do quadratic equations do, Zaves? What do they look like? So linear, we know it's like a straight line. It could be increasing, it could be decreasing. Profit, loss, all that sort of stuff. Quadratics, they are what we call parabolas. So they can look like this, which we call convex, or they could look like this, which we call concave. Now, we have lots of these examples in architecture. Anyone think of a massive bridge? Sydney Harbour Bridge, some of that's going to fit a quadratic, a parabola. Projectiles. So if you're firing rockets, if you're firing a tennis ball, a basketball, and we will look at some of those applications of how it can be used in sport. Volleyball even, right? So you can see what's the height you should aim for, all that sort of stuff. Now, you're not going to do that on the court, but, you know, it's got applications. So that's why we're going to do this, and it's going to take up a lot of term 3. And your calculators will really come into the fore for that. Okay, so we're going to go through. You did some of this in year 9, but we're just going to take it up a little bit of a notch. And you'll see that the first bit is indeed saying review of year 9. So a little bit of a heading, and today's date, factorising. We should realise or know what's the HCF stand for. Highest common factor, and it has to be. If something's fully factorised, you've pulled out the highest common factor. So if you were following along with DayMap, we are actually starting, just some of the basics here. And I don't think we have to do all of question 1. I really do like question 2 and 3. They graduate, all right? So if we look, maybe I'll do the left-hand side. What do you reckon? Yeah. Shall I do left? I'll go left. Go left. Bare minimum, we're going to write these. Now, in your book as well, I don't want you to just write the answer. You are going to write. Let's go pink. No, we'll go white. You are going to write exercise blah, 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 1a, 3x squared plus 5x. Okay, who wants to talk us through it? You can probably already see what is our common factor. X. Fantastic. So we put that out the front. We pop our bracket. And there's going to be 2 different ways that your brains are thinking throughout here. You're either going to be of the, right, x times what gives me 3x squared? 3x. And x times what gives you 5x? Well, clearly it's 5. Is anybody thinking a different way? Some people might just go, well, I'm just dividing this through by x. 3x squared divided by x is 3x. 5x divided by x is 5. Because that's what you're doing by pulling out that common factor. Easies? Right, B. No, it's not B, it's D. Okay, again, we're looking. We want the highest common factor. Fantastic. If you pulled out the 2, yes, it's common, but it's not the highest common factor. So 4x. I like how that was said too. 4x. It's easy. Yep. What's going to go in my bracket? Yep. X minus 2. Take 10 seconds out of your busy lives to double check. 4x times x, yes, gives you 4x squared. 4x times 2 gives you 8x. Again, it's nice. It's easy. But you know as well as I do, your times tables sometimes, you know them, but I will obviously say sometimes 2 times 4 is 6 because I'm adding and timesing and so double check, please. What can you tell me about G, GGO? There is a negative, but now this isn't a deal breaker, right? But we like to put I like to put my highest powers first. So when I'm writing this, I would actually write this as 8x squared, take 4x. And then I'd pull out the common factor. Yes? If we had something like this, h, I put the minus 10x out the front. So if you're looking at h, what would your common factor be there? All right, so people are saying 5x, negative 5x. Your textbook would have it as negative 5x. And you could argue that's probably the best one to do. If you pulled out 5x, I'm not going to have a major issue. It just means inside the bracket you've got a negative and it looks ugly. But I still would go, same thing. Is that all right? So I'm not overly fussed with the negative bits. Anyway, so just give you a momentito. Can we just finish that off? The whole reason that we're doing this it's because we're trying to solve a quadratic, right? And what will eventually happen is they will tell you, 3x squared plus 5x. Instead of saying just factorize it, they'll say it equals 0. Now, when you have factorized it, the whole point here is, what's anything times 0? 0. So once we factorize it and we've got something times something else, that would mean, what makes this thing here 0? 0. That's one solution. And then, what makes this 0? not 0. 3 times 0 would be 0 plus 5. That's not 0. So then you're actually solving 3x plus 5 equals 0. Put the 5 on the other side. Minus 5 divided by 3. And those will be your two solutions. Now that might have gone a little bit whoosh over your head just then, but the reason we're practicing this is to get to the end point of being able to solve a quadratic. So they're taking it nice and slow. Oops, all good. Okay, so anyone want to do J? What was it? Yep, X, so what goes in my bracket? Beautiful. Okay, and AX squared, and we're going, I could do this all day, every day, with my feet up in Bali. We're all a little bit jealous, Mia. Whereabouts are you going in Bali? Okay, so we're very happy. It's going to go up a notch. So somebody made a mistake. It could have been me. Okay, it is me. Because I was chatting. I'd like to say this is a deliberate example of what happens, but no. Just so double check. What's AX times X squared? Oh, so that shouldn't be there. They're going to graduate a little bit. If we look at these, I mean, there's beautiful examples that you can follow, but we'll just go through it very quickly. We look. Who wants to expand? Good, nobody puts their hand up. Because there's a shorter, sharper thing if you're looking. Because you're looking and you go, is there something common in both of those terms? The X plus 5. And so when I'm looking at A, when I've got my 3, X plus 5 plus X plus 5, that is what I'm going to pull out as my common factor. So I pull out my X plus 5. When I pull it out from here, right, that's Gonski, what's left in that term? 3. I pull it out from here, I've got the plus X. And I sort of screw my face up at that little bit, and I'm going to rewrite that as X plus 5, X plus 3. If you didn't rewrite it as X plus 3, you're not wrong. That's just me being a bit precious. Does that make sense? So people said D looked a little bit cray-cray. But again, you're going to do exactly the same thing that you have done all along. You look. This is going to be the first thing that you do every single time that you factorize. Everything's on one side. We look, is there a common factor? You look carefully and you can see, obviously, X plus 2, X plus 2. So that's what we're going to yank out. So I pull out my X plus 2. When I pull that out from the first term, what am I left with? X. Thank you. And when I pull it out from the second term, now, when there's a plus here, this bracket is pretty much not necessary because I can now simplify this to be X plus 2, X plus X is 2X, and then I get the plus 5. So didn't really need those brackets there at all. Listen very carefully, please. If there is a minus here, if that was a subtraction, you must have those brackets, right? Because imagine if you didn't, you'd have minus X plus 5 when it should have been minus X minus 5. So when there's a minus here, include your bracket, please. Now, you also asked about H, and I can see why, even F, so F and H are pretty similar. Why do you think people asked about those two? Yeah, and it doesn't look, there's a negative, and it doesn't look like there's a common factor, does it? Right, there is a common factor. The common factor is minus 1. So what's minus 1? Minus 1 times what gives me minus X? X. Minus 1 times what gives me minus 2? Plus 2. And lo and behold, we now have common factor. So I'm going to pull that out. And then I'm left with A. Take 1. Yes? Yeah. Similarly, this is then the next question, like this is question 3. When you look at that, what does x take 4 squared actually mean to you? Pardon? Yes. Now, you don't have to write it if you don't want to. You might just be visualising that yourself. X take 4 times x take 4 minus, what do you notice about the 5 and 20? Common factor of 5. And if I pull out that common factor of 5, oh my goodness, what's going to be in here? Not now. It's not plus. If you put plus, what's a negative times a positive? A negative, and we want a positive. So that's why you're always double checking. And lo and behold, it's minus 4. So now I've got a common factor and pull it out. Okay? So some of you are finishing off Pascal. That's gone on way too long. Should have just been a double lesson activity. But anyway, finishing that. Some of you should be starting this. And what I want by next term is I want 2D.1 finished. And then you're going to refresh your memory of difference of 2 squares and do 2D.2. 2D.1, 2D.2. Love you. Goodbye.